Hi, welcome to my video on converses. Proofs with converses. A conditional sentence consists of two parts, the hypothesis in the if clause and the conclusion in the then clause. Some examples. If an angle is a right angle, then it has a measure of 90. The hypothesis, the if part, an angle is a right angle. Conclusion, its measure is 90. Second one, B, if a triangle is isosceles, then two sides are equal. The hypothesis, the if part, if a triangle is isosceles. The then part, two sides are equal. Practice. Pause the video if you wish and see if you can write these out. Number one, if M is the midpoint of AB, then AM equals AB. Hypothesis, M is the midpoint of AB. Conclusion is the then part, AM equals BM. Number two, if two angles are supplementary, then the sum is 90. The hypothesis, two angles are supplementary, and the conclusion, their sum is 180. Converses of a conditional sentence as the hypothesis and the conclusion switch. Some examples. If an angle is a right angle, then its measure is 90. The converse, if an angle has a measure of 90, then it is a right angle. Notice it's switched around. If a triangle is isosceles, two sides are equal. The converse, if two sides of a triangle are equal, then the triangle is isosceles. Practice. Let's pause the video if you wish and write out the converses. The converses of each. If M is the midpoint of AB, then AM is equal to BM. The converse, if AM equals BM, then M is the midpoint of AB. If two triangles are supplementary, then their sum is 180. The converse, if two angles have a sum of 180 degrees, then the angles are supplementary. So notice the converse is switching the if-then clause around. Okay, let's practice. Practice means pause the video. State the converse of each and why the converse is false, because not all converses are true. If two angles form a linear pair, then the two angles are supplementary. The converse, if two angles are supplementary, then the angles form a linear pair. So can you give an example where this is not true? Well, just look at this. If you make this angle, let's say 60, and you make this angle 120, both these angles are supplementary, but they're not a linear pair, because to be a linear pair, they had to be intersecting like 120 and 60. To be a linear pair, they had to be adjacent angles. If a triangle is equilateral, then the triangle is isosceles. The converse, if a triangle is isosceles, then the triangle is equilateral. So that's false, because if you take this triangle and you mark these two sides as being equal, but there's no third one equal. So just because it's equilateral, if it's equilateral, all sides are equal, so therefore two of them are equal. But if it's isosceles, with two sides equal, it's not necessary the third one equal. Third one, if two numbers are even, then their sum is even. So the converse, if the sum of two numbers is even, then the numbers are even. That's not so, because let's take 3 plus 5. 3 plus 5 adds up to 8, but 3 and 5 are odd. Because two odd numbers, if you take two odd numbers and add them, it makes an even. B, state the converse of each. If a triangle is isosceles, then two sides are equal. The converse, if two sides of a triangle are equal, then the triangle is isosceles. If two angles are complementary, the sum of the measures is 90. The converse, if the sum of the measures of two angles equals 90 degrees, then the angles are complementary. I just write down complement. If two line segments bisect each other at x, then x is the midpoint of each segment. Converse, if two line segments intersect each other at their midpoints, then they bisect each other. And number 4, if two sides of a triangle are equal, then the angles opposite the equal sides are equal. And the converse of this is called the converse of the ITT. It's called the converse of the ITT. That's the ITT. Two sides are equal, the angles are equal. The converse of the ITT is if two angles of a triangle are equal, then the opposite sides are equal. So ITT is equal sides give you equal angles. The converse is equal angles give you equal sides, or reversing it. Number 5, all PLTs from A to D below. State the converse of all these. If a transversal intersects two parallel lines, corresponding angles are equal. That's the PLT. So the converse is called a CPLT. And that's if corresponding angles equal. So the converse, if a transversal intersects two lines so that the corresponding angle is equal, then the lines are parallel. And this is the CPLT, and its alternate interior angles are equal. What we're talking about, if the two lines intersect but the alternate interior angles equal, then the lines are parallel. And CPLT, alternate exterior angles equal. What does it mean? If the two lines intersect If the transversal intersects two lines so that the alternate interior angle is equal, then the lines are parallel. And CPLT, again, converse is just the reverse. The converse of the same side interior angles supplementary. And what do we mean? If a transversal intersects two parallel lines such that the same side interior angles are supplementary, then the lines are parallel. So again, here PLT is parallel lines giving you these four. The converse, if these four are given, then the lines are parallel. Number 6, if a triangle is a right triangle, then the longest side squared is equal to the second side squared plus the third side squared. The converse is if the longest side squared equals the second side squared plus the third side squared, then the triangle is a right triangle. So you can see how the converses are working, and we'll use the converses in proofs. That is, we'll prove lines parallel. That means you need angles equal. Or you need to prove triangles isosceles, you need sides equal. So if you have to prove a triangle is isosceles, then you need to prove two sides equal. If you have to prove two angles are complementary, then you have to prove the sum of the two angles is 90. If you have to prove two angles are supplementary, you have to prove their sum is 180 beforehand. If two lines or line segments are parallel, then you have to prove the converse of the PLT. Two corresponding angles equal, or two alternate interior angles equal, two alternate exterior angles equal, or the same side interior angles are supplementary. Converse of the PLT. A triangle with two sides equal, you have to prove, if you want to prove a triangle with two sides equal, you have to prove that the two base angles of the triangle are equal. That's the converse of the ITT. If you want to prove a midpoint of a segment, you have to get the two equal parts of the segment. The bisector, you have to prove a bisector of an angle or a segment. You have to prove two equal parts of the angle or segment. If you want to prove an angle is a right angle, you have to get the measure of the angle is 90. If a segment is perpendicular, you have to show that there's a right angle or they have a linear pair equal. And if a triangle is equilateral, you have to show that all sides are equal or all angles are equal. So notice the converse. We'll use the converses in the next video. And if you like my video, click the like button, subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that I have on my YouTube channel called Math Fully Explained. Thank you. Bye-bye.